talking about that why do we need the Typhoon Hill? So for this purpose, first as in academics, when we think of the things like suppose in this picture when you will find, so here you can find this is the SCADA, this is the demand response, this is the data handling part. So all these parts actually this is example of a microgrid where we can go through all the specifications to our life, which is finding out the right sizing and configuration, and we are validating their performance at each and every steps. So we are having the generic library models that is setting up the systems that becomes easy. Now, the first thing, like suppose we want to do this, and for this we need to have some sort of a setups that like if we are working on microgrid, so how the microgrid should be customized, what kind of um, things we are using, means number of means relays, or you can say about the inverter controls, what we are doing. So that is required. And for that, we require the hill design, that is how much percentage of embedded things we are going to put up on our this design. And that design as an engineer, if you will think, or as a researcher, or for making the things patent. So these are some of the important factors that comes to our mind. That is, we should have the reduced development cost, then reduce life cycle maintenance costs, then we should have the simulation time step down to uh, simulation to shorten the time. So time to time market to stay competitive. So we will be using all those things. Then besides this requirement, when we have gone through the design part, now the process comes that we should test it with whether these are going to be better schedules with HIL, or we are having the less software bugs, or we are having more new softwares with HIL. So that is the things which we need to test. For that purpose, we require the hill testing, and that ensures the reliability of a rapidly evolving, that is, device under test regarding the performance as well as the safety. So these are the purpose as an engineer we are using here in our Typhoon Hill, and the other users have also opted keeping all these things in mind, and this led to the uses of Typhoon Hill to most of the people. As an academician, when you comes to the thing that how do we select HIL, as there are a number of tools are present from different backgrounds in the market, but how should we select? So these are the few key points which we have designed through our experience. The first, what I feel that it should be easy to use and we can learn it easily. Then we should have the publication productivity, that whatever the work I'm going to work, that should get a platform where we are able to produce our publication. We can get that sort of a productivity. Then we should have the numerical stability, and the most important part, that is the technical support. In case of any need, we should have the technical support. So we are having technical support in two forms already. We are having number of tutorials on HIL Academy, where you can find each and every answer to your question, whatever coming to your mind, and then support from Corps Infosystem. And also there is one total page on our Typhoon Hill website, that is support, where you can create a ticket regarding your queries. So that is, you can say, like one stop shop, you can say. Then we have the flexibility enjoying with this Typhoon Hill products, that you can go beyond your innovations, means beyond your ratings, whatever you are going to apply. Then after producing all these steps of the thing which you have worked on, then what is the return on your this time investment you are going to get? With your paper is going to be published, then your things are going to be patent, or how it is going to reward you. This again help you to define the selection of the Typhoon means a selection of a hardware in loop device means whatever platform you feel it easy, you can opt it. So these are the few things which you can keep in mind while selection. Now for the selection purpose, after the selection purpose, the things come the different development stages as we are working on several development stages like on first which we worked on like in our first mode phase. If I take from the nowadays it is a trend of simulation and other things, but earlier what we're having that we need to purchase some sort of a hardware component and then we try to test on it, and if it fails then going to be the product damage, as well as we were facing the financial crisis. But in this simulation time of era, so we are having like virtual hill simulation, real-time simulation, controller hardware in loop simulation, power hardware in loop simulation, and then full power test you can say, or we are also performing RCP. So these are some of the simulation steps which we are following, and which simulation development stage suits us best, accordingly we can follow that. So first I start with the simulation. If the students are participating, faculties, of course, they are very much familiar, as well as the scholars who are participating. So when I say for simulations, it is just like a an approximate imitation of the operation of a process or system that represents its operation over time. That is, it can be used for the performance tuning, optimizing, safety engineering, testing, training, education. Or you can say it operates on a platform of integrated software and hardware components, means that in this manner system accept the input from the user like physical controllers and produce output to the user in the display form. Or in very simple words, like earlier for performing the complex mathematical uh, calculations, we were using calculators. Then came the scientific calculator when we used to take out to work with logarithmic or trigonometric parts. So we were using the scientific calculator. Similarly, in electrical domain, simulation is performing the same task where we need to work with we have to understand the modeling principles, constraints, or uh, as for when we need to work for the machine solvers. So like all these things, this is the part of simulation. So here you can see this red dotted rectangle represents that for simulation we need only simulation software and one means a PC or a system, whatever you are having, so that you can have like this. And you have to get your model definition requirement, that you have to define your mathematical modeling using the characteristic equation or the parameters of the actual hardware. Then as like we draw on paper the schematic diagram, similarly we have to draw the design using the components from our schematic library, and simulation will perform the solving your differential equation of a plant or the mathematics of controller together using the normal PC or a laptop. So that's why it is recognized by the red dotted line. That means that here you are using one simulation software and only one means PC. Simple you need the thing, and we are going to process the plant and controller in the same environment. Now the advantage what you get here is that you have the flexibility to work anywhere. You can go beyond or below the rating. Suppose like if an induction motor works at 2 ampere speed and its starting current can go up to means can be 2 ampere, but if you want to make it up to 8 ampere, so that flexibility you can enjoy with your simulation. Only the disadvantage you are getting here that you are working in non-real time, and regarding the accuracy, accurate results as per your desire that you are not able to get. Regarding a real-time simulation, you will find that here again the components have been divided into means framed by two separate red rectangles. So here you can see that first red rectangle, this shows the plant part, and this second red rectangle shows the controller part. It is just like similar to the simulation part. Only the thing is that in real-time simulation, we are going to process both plant and controller to model in a PC. And after compilation, both plant and controller going to process by a specific device called the real-time emulator. So of course, as we are using the two processors, one is your PC and another one is your real-time simulator and simulation software. These are the requirements. So due to the uses of your real-time simulator, the cost is a little bit increased. Coming towards the controller hardware in loop simulation, when we talk about the controller hardware in loop simulation, so here you can see two different colors, means controller is framed by a blue rectangle and plant is framed by the red rectangle. That is, here our controller is actual and plant is digital. So this is controller hardware in loop simulation and we are using the actual controller like this. Here you can see that we are using the actual controller and plant is our digital, and with the usage of the actual controller, we are able to cover the high fidelity tests with this controller hardware in loop simulation. And this is most on the trend because this is cheap and best. It doesn't cost much more. And test coverage is as per our requirement. The results as per our requirements. So this is nowadays much more trendy. Similar of the power hill, that is the we are using an additional tool, that is power amplifier. I should proceed you with this first card like this. So here you can find that in PHIL, you will find that some part of the plant and some part of the controller is actual, and some part of the plant and some part of the controller is digital. Okay. So additional tool which we are using, that is the power amplifier. So that is making the cost little bit higher. And in full power test means all the components are actual. These all are in actual form. We are using all the components in actual form here. Okay, so this is the full power test. So that's why the cost is of course very high. But regarding the fidelity, if you will compare, so it is of course when we are using amplifier, it is little bit broadened. Means from controller hardware in loop. Using the full power test, the fidelity is again broadened because we are using the full power test components, but that is not making much more difference. On an average, this one finds to be cheap and best for the testing and development phase. When I was talking about this power amplifier, so here you can find that this is the way how do we interface using the PHIL interface, and this is the device under test. The power amplifier, you can use it from Synergia, Regatron. There are a number of companies are there which you can use it. Then next is the rapid control prototype. So in this rapid control prototyping, what happens? That our plant is actual. Here you can see this is the real lab setup performed by the Co-op's Infosystem technical team at Anurag University, performing the rapid control prototyping of 5-level MMC wind energy system using the Typhoon Hill 402 only. And we have designed the controller inside this, means as our controller is virtual and plant is our actual. So this is the plant part and this is your inside your PC which you are finding the schematic upload image. So that is your controller. So to sum up the points, we have gone through like simulation where we are modeling and validation using the PC. And then we are going through the real-time simulation, that is means validation of developed system in real time, and rapid control prototype, that is digital controller tested with physical plant, and controller hardware in loop simulation, that is actual controller tested with digital plant. So these are the points. I think the things for all sort of simulation which as of now researchers and industrialists are using. It is clear with the development, with all the stages we have passed. Here it is just like a case study about the actual lab setup as well as the CHIL setup. So this is a kind of a CHIL setup. As you can see, this is the actual controller, and this is the laboratory setup for 700 kVA. VSA used for transformer testing. So here you can see this. This is the controller cabinet, converter cabinet, filter cabinet. So what is done? That controller cabinet is kept as actual like this, and converter cabinet, filter cabinet, this is replaced by HIL 400 series, which we were using earlier. And you can find the setup results. The laboratory setup and HIL setups doesn't make a single difference. And so is the comments from the CEO of EnerDrive, that is the Andres Rich, that real control signals in real time with real hardware. It is easy to operate as a software simulation package. So this is the most important part of our this presentation. That is the technology, that how it makes us different from Intel's, as maximum number of users may be present here. They are the Intel users. So like, first of all, we should generalize. When I talk generally, it's based on Intel processor. So when I talk for Intel processor, then there they are having CPUs as the main processor. The main processor is CPU there, and the secondary processor is FPG. But in our case, in Typhoon Hill, we are having FPGAs as the main processor and CPUs as the secondary processor. In FPGAs also, again, we are having the normal FPGA, that is the that performs the logical part provided for logical action like Artex, Kentex, and Spartan. And one is a system on chip based, that is providing us the less delay, less losses, and using the ARM processor. Here you can see that we are using ARM Cortex A9. That is again advanced RISC machine, is a family of reduced instruction set of computing architecture for computer processor configured for various environment. And ARM Cortex A9, it is a multi-core processor providing up to 4 cache coherent cores used by our Typhoon Hill technology. And this is the device series. Here you can see these are the device series: 402, 404, 602 plus, 604. 602 plus now we are not using, and 606 is the new launched one, superior than all of these, even 75% faster than 604. So these are the several series which we are having. Now here in our CPUs, you will find that we are using system CPU and the ARM CPU. Now how all this schematic part you can also see. The components framed by this green color. So these are partially simulated on a system CPU. And for system CPU, we are using the microblaze processor, which is used for slow dynamics part, that is handling the components of electrical domain like RMS value. And microblaze is a soft microprocessor which is designed for Xilinx field programmable gate array. And as a soft processor, microblaze is implemented entirely in the general purpose memory and logic fabrics of this Xilinx FPGAs. Regarding this user CPU, so this is directly user under the user control. So here you can find that the components framed by the blue rectangle, that is under direct user control, and the and the components which are unframed by any of the color. So these are simulated on Typhoon FPGA solver. Now what is the FPGA solver? So these FPGA solver is introduced by Typhoon Hill, which is required to understand the fundamentals behind modeling principles, constraints, and other solver processor architecture. Like suppose these you can see SPCs, we are having an array. So this is again the basic building block of the circuit solver. Like it is in charge of simulating electrical circuits that consist of linear passive elements, both constant and time varying, converter blocks consisting of ideal switches, and contactor that is based on ideal and non-ideal switches. So these SPCs blocks are interconnected through dedicated communication lines, which allow them to exchange variables with the single simulation time step delay. We also have the time varying and non-ideal switches. So these are like time varying and non-ideal switches. These are optional. As for example, if I tell you that in 402 we are having 6 configurations. So in 402 we are having the 6 configurations. So these time varying and non-ideal switches, these are optional. They will only exist in a configuration 3 and 4, and in the rest of the configuration they are absent. So if you want to make use of these components, you have to go through the device table. I will show you when I will be proceeding on the hands-on part. That there you have to find this in the device table and you will get according to your requirements. You can switch to the configuration, that what kind of a configuration do you require, how many number of machine solvers you want to involve, how many number of signal generators you want to involve, and how many number of lookup table channels you want to involve. As per your requirement, you have the flexibility to change the configuration without disconnecting on the same schematic platform. Even when you're working with hardware, then also you can change your configuration without disconnecting your hardware. Then signal generator. So it is in charge of generating the arbitrary waveforms at the full simulation rate, and it is mainly used for independent voltage and current sources. So it employs you can say a linear interpolation, that is where waveform sample rate is lower than that the simulation rate. And again, the number of the signal generator channel depends on the solver configuration. Lookup table, here you can find that the lookup table is used to simulate the behavior of the non-linear elements such as the PV panel, battery, and the saturable transformer. And as per your requirement, you can switch on to the configuration if you are requiring those. Machine solver, it emulates a single electrical machine model, including its electromagnetic part, mechanical part, and speed measurement devices such as encoder and resolver. Then we have the PWM modulator. So this is the multi-channel triangular PWM modulator, which can be used both internally to drive the internal converter models and externally through the digital outputs. It runs on FPGA internal clock, typically 150 megahertz, and features a built-in dead time period. And again, the number of the PWM channels depends upon the configuration we are using, with 20 nanosecond PWM sampling time to 500 nanosecond simulation time step with third generation, and 200 nanosecond simulation time step with fourth generation. We are able to provide the ultra low latency, that is marking the industry standard for ultra high fidelity real time emulation. So these are the features, and this is how we the technology differentiate us from the Intel's one. I hope this part is clear to each and everyone regarding the technology part, because this is when you have understood about the Typhoon L technology, so most of your questions you must have got the answers by your own, that what makes it a little bit different. Shall I proceed further with further slides? So here there are number of series, like we are having Typhoon 4 series and 6 series. We are also having the M series, that is the microgrid series. In 4 series and 6 series, you will find 402, 602 plus, those who are still the user of 602 plus. But as a new, we are not moving ahead with 602 plus. We are moving with 604 and 606. So these are the third generation devices 402, 602 plus and 604. That is their simulation time step is 500 nanoseconds. Okay. And with the fourth generation, that is the 404 and 606, we are able to have the simulation time step down to 200 nanoseconds. Okay. So this is the thing. Then with the physical appearance, you are able to find that what kind of a box does look like 402. Then 404, the similar structure you will find. These are the pins for the analog input output pins, AIOs, and pins are provided for the interfacing purpose and for the DIOs. So these are the pins you can find here. Then in 604, you can find that you have the 4 ports you are finding 1, 2, 3, and 4. Similarly, for 606, you are also having the 4 ports. Actually, 606, it is the combination of 404 and 604. In a very short, you can see about the comparison for HILs 402, 404, 602 plus 604 and 606. In details as per your requirements, we will let you know later on. But here you can find about the model capacity, then IOs we are having regarding the connectivities and paralleling. With 404, you can cascade up to 4 units. With and 606, we are able to you are able to cascade up to 16 units. So this is 402 works as a standalone, and this is the 404 device. The back portion you can see that how it can be connect to the HIL devices in parallel. How can we communicate? How can we interface through Ethernet, CAN, RS-232, GPIO, HSSL, etc. And this is the connectivity for 606 with the additional part, that is we are providing you the M.2 slot for the data acquisition. That is the part which we are providing with 606 and several other connectivity like 2 CAN and 2 CAN FD ports. So this is the some features which should be highlighted as in detail if we will move on. So there is a long list for the technical specifications regarding all these series. Moving ahead with M series. So already informed you that microgrid is a kind of a collection of the HIL devices or integrated protection relays. So that is there. So here in this Typhoon HIL, you can find out this part regarding your design, that what kind of a design we can have. One figure you can find this, that this is again one customized part, and this one is the another customized part. Means this one you can find that this is a smaller microgrid, this one is bigger than this, and this one is the most biggest. So I'll discuss with these parts so you will understand all the parts, because here we have it is a customized list of number of things which we can use and which we can perform. So we have like here you can find that earlier we were this is the picture when we used for the first time 602 plus. So here you can see this is one 602 plus box, this one is another 2, 3, 4, 5 and 6. So these are the 6 HIL 602 plus boxes we used here. Then this is we used the battery energy storage inverter controller we used. Then this is for solar PV, wind inverter controller we can use. Then here the blue color which you are looking, these are the two relays which we have used by SEL and 2 relays used by ABB. So this is the relay which we have used by ABB, and this one is the diesel genset generator, which is EasyGen 3000 Woodward, because it is pioneer in that, so we have used it. So this is how we can customize. Now in this figure you can find that here we have used one production relay only from SEL and one from the ABB as per the requirement, and in this one you can find that we haven't used any sort of a production relay. only use the two HIL 602 plus boxes with diesel genset and one ABB relay we have used here. So this is how you can customize as per your requirement. Regarding the battery energy storage system, so this is a kind of a battery energy storage system where you can find the power switchboard, where you have the gateways, you can have the inverters, you can have the battery, you have the grid connection, and you can connect with the SCADA panel. Like this is the microgrid test bed, and this is the battery energy storage system, and this is how you will find the HIL compatibility with this, because this is ensuring you the lower project risk, because all the means this is already tested, a wider test coverage including all the means full system level operation, extreme voltage condition faults and communication layer test. So this is saving time as well as money as compared to your PHIL testing. So this is uh, regarding the HIL microgrid test bed. The main purpose of the microgrid test bed is to test and validate primary and secondary control, communication and protection under all the operating condition, including all the faults in both the islanded and the grid type. Here we are providing you the some accessories like HIL Connect. So HIL Connect works as like true plug and play interface. You can directly interface your controller. Like suppose you want to have the sensors for the signal conditioning. So you can have the sensors, like you want to sense the temperature, you want to sense the current, voltage, like that. So you can have. If you want to have the control feedbacks, so this is again can be used for the signal conditioning, and for control output also signal conditioning you can use the HIL Connect. Again, this is HIL Connect we are having in two forms, that is the universal HIL Connect, as well as when customer wants to have their as per their own requirements, they are having their some own data, and accordingly if they want to means customize it, so HIL Connect can be customized also in the form of a modular HIL Connect, that is also we are providing. Then the other accessories we are having the breakout board. So breakout board is just like simply as we do wiring by wiring connection on a simple PCB. Similarly here also we do the same sort of a connection. It is having 192 pin, and you can connect. Then we have the launch pad interface board, DSP interface board, micro grid DSP interface board. So those who are more towards the power electronics side, and they want to use, so they can use TI cards from the Texas family. And here in this DSP interface board, if you can see, so this is a one slot, means here you can interface only one controller card. With micro grid DSP interface, you can find three slots, 1, 2, and 3. So here you can interface three controller cards. That is the option available with microgrid DSP interface. So these are the secondary things, optional things as per your requirement with Typhoon HIL. This is again the example of PHIL solution which we have provided with a world-class power amplifier. This is how you can find the device under test, and we are using the power amplifier from Synergia, Chroma, SPS, Rigotrain, NRG Lab, and others. So like this you can have it. This is the example of, I'll just go through quickly with these slides. Just to show you the setup, the first microgrid testbed was installed in year 2018 under Indo-US project at IIT Kanpur. And this is, you can find that how it is customized. This is the Quarbs Info System team. And these are the team of Typhoon HIL, technical team of Typhoon HIL. So this setup has the capability to simulate 24 three-phase, three-level converters and time step down to 500 nanoseconds or 450 plus IEEE. The standard node of bus system with loads and source connected at a time step down to 10 microseconds. Similarly, here you can find that the similar microgrid testbed was installed with NITTR Chandigarh in year 2019 for a smart grid and electric vehicle study. Only the difference between that IIT Kanpur and NITTR Chandigarh is that here we have used the additional smart grid controller with inbuilt communication protocol to exchange your data Modbus. So like that, the communication protocol smart grid controller that is from AIT, Austrian Institute of Technology. One is smart grid controller we have used. So this is, you can find. This is again installed by the COBS info system team there. Microgrid testbed is at IIT Bombay, installed by the COBS info system team. So here you can find. This is the test bed at Massachusetts Institute of Technology, a kind of for the purpose of case study. We have involved like in model part, we can have the diesel genset, solar plant, battery energy storage, and over more than 40 protective relays. It has been there has been used, and more than 50 circuit breakers. And in the loop, they are having the microgrid controllers from GE and Ayrton, and then they have the two genset controllers from Woodward, then ESS controller from EPC Power, then solar inverter controller from EPC Power, and three protective relays from SEL. Then simulation time step and HIL setup and protocols they have used, that is the Modbus, TCP, and EODP for the data logging part. This is the case study for Hitachi ABB Power Grid eMesh. Just to show you the picture, the full success story here. The link is there, and you can find out on the Typhoon Hill page. Regarding the Typhoon Hill, there are a few features like we are having inbuilt blocks, which is reducing the time for the converters. We can directly use it, and the compilation time is less than 1 minute. And again, when I say that compilation time is less than 1 minute, so that I'm speaking for the professional computers and professional systems, because when we say, and sometimes when the users say that you told that compilation time is less than 1 minute, we are not getting. So this is the time with using our real time, that is also we are getting compilation time less than 1 minute for any of the complex model. Again, it depends upon your processor and system, how much RAM and other things again matters for that. Then regarding the compatibility, so Typhoon Hill is compatible. It has the compatible with the other platforms also. You can have the automatic code generation, automatic code compilation, or automatic code loading. This is all done by the Typhoon Hill software itself. You don't have to go ahead with this. We are providing you our own software and own hardware. And forward compatibility, as I told you, that with older versions like those who are having 32 bits, they can use the older versions of Typhoon Hill. But currently we are using 64-bit. So for this 64-bit, the current version is 2020-22.2. And very soon, like in July or by the end of June, we are going to get another update. So with this, I would like to tell you one more thing, that simulation with Typhoon Hill is free of cost for unlimited number of users with lifetime free updates, and the real-time simulation, that is C-Hill, is on cost with lifetime free updates of firmware and software for unlimited users. So all these points I already discussed about the simulation time step down. So this is with the third generation, and with fourth generation we are able to have 200 nanoseconds. Regarding the processor time, like compilation time is again less than 1 minute, and processor time, the answer is like we are also using the combination of FPGAs and CPUs, and similarly the other parties are also using the combination of CPUs and FPGAs. So the answer to this question is that when we are using this FPGAs and CPUs, so FPGA is customized for a for a specific part, for a logical part, because FPGA works on a very long hard description language, and it is just like a blank worksheet. Means it is like a blank sheet. You can entire its FPGA's entire internal hardware can be reprogrammed, reconfigured as the user is permitted to determine the logic of each block of the system. When I said this, that it is based on Verilog hard description language, so it doesn't mean that you have to learn for using the Typhoon Hill. You don't need to learn. I'm just telling you about this. So FPGA is actually also ideal for parallel system where multiple tasks can be performed simultaneously as they are electronically wired in the form of a discrete programmable logic blocks which can be configured to suit the user needs. When we talk for CPU, so this is a chip which is executing a program that is based on a specified set of instructions, and CPUs are optimal for a single system where code needs to be executed in a sequential or the linear manner, and it lacks in implementing parallelism. And we have the flexibility, like I told you about the flexibility that FPGAs works like just blank sheet, and for complexity even fixed. With CPUs, you can go for fixed set of internal blocks and process that are already designed by the manufacturer. But with blank sheet like FPGA, that is configurable and modified according to the user. So that's why we are using the combination of two, because CPUs and FPGA is incredibly flexible and efficient, as CPU part handles bulk of the data processing, mostly general computing, and FPGA logic blocks comes into the play for specialized and custom tasks which can be configured according to our needs. So this is responsible for the fast execution speed, because nothing can beat a dedicated piece of hardware design to perform a single function. Like FPGA will always execute faster than a software code which is running on general purpose CPU. So this is the logical way we can think, and that is implemented in Typhoon Hill. Then you don't have to go after the different support teams for this. These are the several applications. Typhoon Hill find its application in the field of power electronics and drives, power system, aerospace, automotive, microgrid and smart grid, shipping and marine, power system production, medical devices, control system, PMU and synchrophasor study, then power quality, HVDC and facts. There are more than number of published papers present on Typhoon Hill website. I'll show you when I'll go through. Don't forget to register on Hill Academy, because this is going to help you out very much wherever you are stuck, because there are number of tutorials given there as per European standard of time, and this is again a platform where you can also give your contributions. You can create your own materials. You can use the platform for remote sharing purpose. So that is also possible. And there are several courses are given, which we will be exploring you in these 5 days, how to solve it, because today we will be completing a sort of a Hill fundamental part. So today you can try for the Hill fundamental test, which is already present on Hill Academy, and that is the quiz and that is the test which you have to pass and generate the certificate on the next day. Or before this training completes, you have to generate the certificate for the 5 courses. By there are video tutorials are given besides our hands-on practice given to you all. The videos are also present there on Hill Academy. Before going to one exam, the full syllabus is covered there. You have to go through those. You have to give the exam, and then you can generate the certificate. When you crack the 5 courses are Hill Fundamentals, Hill for Power Electronics, Hill for Microgrid, Hill for Communication Protocol, and Hill for Test and Automation. When all these 5 courses you have cracked, then you will get a Hill Specialist Certificate. So these are some highlights for direct import and indirect import. As per the requirement, will we move ahead? So till now the things are clear to all, because this is end to the presentation, and here we come towards the website page. Then we will move ahead with a small hands-on to give you a taste how to use the schematic, how to see your things on SCADA, how you can use your this virtual hill software. So as you will simply type Typhoon Hill, and on this platform you will be able to get this part. Inside this solutions you will find drives, and when you will open each of the things you will be able to get. Then in resources, inside the documentation you will find the white papers and published papers. When you will go for download, so inside the download you will get the software download. So the software which we are using BHIL, so that you can download it. Then in products you will again find the virtual will, when you will directly click it here, then again you will get for other things like XIC integration and this. So again you have to go through the support page and you have to create your genuine things. Then the Typhoon Hill will open the platform for you all, because these platforms are again optional, not available for each and everyone. For the community, so you can go through the industry highlights. Then you can go through the success stories. So the success stories page, which I have told you about, the Hitachi, ABB, Schneider, lots of success stories are present there. You can go through the feedbacks of all those. Now how to register? When you will go to the My Typhoon, those who have joined today or maybe some late. So this is the first form you will get. And already a quick start guide has been forwarded along with the activation key. So this is the first form. After filling this form, you will get the activation key from the Typhoon Hill admin, but the activation key we already provided. So you have to fill the second form. So I just log in. So from the subscription part, you will download the license file. From the download portion, you will download the software for your Windows, or if you're the Linux user, you can download for the Linux. This is the support page. This is the most important page. I think everyone will be needing if you are using this Typhoon Hill control center. So here you can create your ticket. You can select your topic like general if you have selected your topic, and you can uh, create the ticket like this. Select your topic, create ticket, write down the issue. If you are having some files or something would you like to give, so you can share, drop your files here. You have to mention your version, which version you are using. Latest is this 2020-22.2. And by the end of June or July we will be getting another update, because quarterly our software is updated, and with the software update we are able to get the firmware update also. We need not to wait for months, that we have to wait for months or 6 months, because with the software firmware is already updated. Then you have to select the HIL device, whether you are working on virtual hill or with the real time emulator box. So you have to select that particular operating system which you are using, that you have to select. You can use the hill interface if you are using any, and you can create a ticket. So the query will be received by the Typhoon Hill people, but please log in with the general details. Otherwise, you have been received means software or login part should be very clear. Otherwise, they won't respond to you. Like NIT Delhi people, if they are having 402 box, and I'm just giving you the example, and if they are using the activation key of NIT Delhi, so they have to log in through that particular credential which is provided with two type to NIT Delhi with that HIL 402. If you are facing any issue, if you are using the 402 activation key or something like that, so essential credentials should be correct. Otherwise, they won't respond to you. They won't consider you genuine. And the participants who are as a trainee, so they have to mention that yes, they participated as a trainee, they worked as a trainee. So means under this program they were explained these things, because training license which we have provided, that is valid up to 60 days. If you had From today, your day's countdown will be will be started like that. So you have to, when you want to use it for the further also, so you can post a ticket to the support system. So as per your genuine reason, you have to define your reasons very genuinely, so they will extend your this license part too. So this is the important information which I wanted to convey using this Typhoon Hill support center. And in quick start guide, the installation features are already there, that how to go step by step before creating a ticket regarding to any query. Go through this knowledge base page. Here the different questions as per the feedbacks of the customers, we have assembled the answers. Maybe your question from this FAQs which you are looking for. So you can go through this FAQs. Maybe your answer is present here. And if you are unable to find your answer here, then please go through this process. Okay, so this is the thing. Then in download, you are having the documentation part. So this is the first document, that is the Typhoon Hill Quick Start Guide. There you will find each and every option. Hill documentation, technical notes for analog output, calibration, battery, all these things are available. So you can go through. Is that clear to everyone regarding this software part, queries part, questions part, that whenever you are stuck technically somewhere, how to progress it forward? Am I clear to the participants? Yes, you can speak up, please.
Yes, madam. But one doubt we have. About the activation key you have provided, it is valid for only up to 4 days. It is showing like that. Can you please clarify that?
Were you already using this activation key before, or you installed it today?
Today only. Today only we have registered in that website, my typo. So in that it is showing valid up to 30th of this month.
30th of
30th of this month. June.
okay, 30th of this month. Could you please post a screenshot to the mail ID I'm providing on the chat? Is it possible to provide? Am I having the access to get the chat?
Yes, ma'am. Yes, ma'am. Actually, whenever we down,
Yes.
when we are downloading, at that time it's showing that it is already used 2021 June 21 to up to 30 June 2020, like that. I think same thing problem.
So you can post a picture. You can write down the mail ID for me. That is kp@coaps.com. And the support page which I have given, there you can directly mention that you are undergoing training which has started from today in NIT Delhi, and you have received this activation key. On the support page I told you here you can book a direct ticket. So you will within 20 means within 5 minutes they are used to give the reply. If they are on holiday, so maybe 24 hours. So on this page you can write that, and you can drop the file for that license part, that this is showing this. You can print a screen, means you can click a picture and a snapshot you will provide, and copy to me kp@coaps.com, or you can tell that you are undergoing through this training, because they are knowing that in NIT Delhi we are upholding this training. Okay, is this clear? And I'll also talk to Typhoon Hill people, but I need some files that yes, the validity date is like this.
Could you please provide your mail ID in the chat box?
Okay. Have I given the chat box option available?
Yes, madam. We got. Someone posted kp@coaps.com.
Okay. Then it's fine. And if co-ops team, if you are available, you can provide some other mail ID also, that meanwhile giving the presentation, you can post these things, so that by today or tomorrow, these people will get the reply.
Madam, I have attached a screenshot for a while. You can check.
Okay, sir. Thank you. Thank you so much, sir. Then coming towards your Typhoon Hill Control Center. So this looks like this. This is your Typhoon Hill Control Center. And inside this device manager, you will come to know if you are connected with any HIL device. Like I am not connected with any HIL device. So it's not showing, it is showing that unable to detect any HIL device. Like here, if you want to load any setup, so you can load your setup. If you want to add your IP address or something for Ethernet connectivity, that also you can get. Here when you will click, you will get the updates. Want to check the updates. If there is any update will be there. So this icon will show you for the update. Here you will get the update option too. So this is about the device manager, and here you will get your device name, serial number, device ID and configuration directly. So by clicking on the configuration, you can directly change the configuration without disconnecting your hardware. Then in the firmware manager, when you are connected with HIL device, and if your HIL device is not updated with your current version, so it will ask that update is available. You have to simply click on the update available, and your firmware of the device will be updated. Test and calibration tool, like if somebody finds till now, up till in 40 years, I think, when the co-ops is working, and since 2008, when Typhoon Hill come to the picture, and 2008 co-ops took the Typhoon Hill products, till now we haven't faced any issues regarding the hill boxes or something like that, because this is that purpose. Like if you are facing any issue, so with PyTest we are able to test and calibrate your such issues, and we will means clear all your part. So whatever error you are getting, or any hardware problems you are facing, so that part is. And again, for this you will get a separate license for on request on the Typhoon Hill support page. This Typhoon test ID part, here I will only today I will just brief it out, because the last day we are going to have one session on this Typhoon test ID. So in Typhoon test ID, this just works like a pre-certification tool. Like if you have innovated something and you design, then you want to have tests. So with the PyTest, you can have this platform for test and automation part. This platform is designed with pre-certified things as per international standards, AIT standards. Suppose for microgrid, we can have BDW test. Okay, so like these, some tests are available for MPPT. We have SOREP like that. These are the tests. The most then the parts which are left, that is signal analyzer. So signal analyzer is just similar, which the component which we will be using in HIL is SCADA. That is the capture and scope. That is the similar part like signal analyzer. And these all are the additional tools. The main tools are these, and these are the additional tools. Now, when I click on to the waveform analyze, means waveform generator. So inside this waveform generator, you have two files, that is the PV file generator and the source file generator. Suppose if you are having the PV, you purchase some sort of a PV panel and you have the manufacturer details, so you can fill it. But if you are not having the manufacturer details, so you can switch on to this EN50530 compatible, and you can use these data. So you can import your IV curve. You can generate your IV curve, like if any IV curve I'm taking, I'm having, which is stored. And if you want to have a preview, so we can get a preview also. Here it is irradiance, that is you can change as per your requirement, and temperature you can change. If you want to make it like EN50530, so it is compatible. So this is about the PV curve. Here you can have the option to save the figure into the image part or something. You can use it. Okay, and you can, from this portion, you can reset the original view. So like you press it and you can have the original. Then the other portion which we are having, that is the source file generator in waveform generator. Suppose you want to have any source file. Suppose I take any file. So this is a form of a continuous waveform. So using this marker, this continuous is changed into the discrete part. And when you will select with this, you can select horizontal. With this marker, you can swag and swell like this. You can provide spikes at different time. This is possible. You can also select the horizontal one. And when you are selecting the horizontal one, so this is, you can like this. You can also add and multiply, like suppose for this multiplication, I'm multiplying through a small number so that you can get the change. So it is multiplied by 2 and you can see if I add something like 1, if I add, you have to press enter. This background should become white. So it is added. If I subtract, if I want to subtract, so I can subtract like -10 or something to show you the difference. So it is subtracted. And if I add something like this, you can add. So these are the things which you can perform it. Then you can change your time step from here in any of the points like I changed. Then here time unit you can change like seconds, milliseconds and microseconds like this. Now suppose if you want to give your own input, like you want to have sawtooth. I took this sawtooth. I defined my own amplitude. Number of periods I want to just see for 10. And you can insert the signal. So okay, I have inserted this sawtooth signal. And again you can save your picture. This is given in this form. Like if you want to zoom it or means like this, so you can get this form. Okay, and again come back to the reset. When you will use this marker again, it will be converted into a continuous wave. So you can use it like this. So this is the purpose of waveform generator. And you have seen about PV panel. Like if you want to have some PV panel file, so you can generate it, you can import it. These are the options available with waveform generator. So now remember, this is SCADA and this waveform generator. All these additional tools cannot be opened along with the SCADA. Either SCADA can be opened or one of these tools can be opened. So waveform generator I have shown. Signal analyzer is similar, which I will be using capsule disco. Now comes for LUT extraction tool. Now suppose, why do we require the LUT extraction tool? So suppose here, if I take any converter, like any converter I am taking, suppose this one, where I can show you the things. So suppose you click on this and you want to go through the losses. And on those losses, you want to have some sort of a file which you want to choose, or some values, like suppose for voltage table, I'm clicking it and visualize a lookup table. So you can export your this, if I put it, so you have to plot the selected data. You can choose like this, you can choose. So how to make it, how to choose it, and how to export all these things, like you can export CV or export image like this. So this you can fix your data like this. So in this case, similarly for the variable components like for inductor and other parts, you also need to visualize these parts. So for this part, suppose I'm having this LUT extraction tool, you can upload any image I do have one image like, okay, I take data sheet for silicon carbon MOSFETs. So this is the thing. Now here you can see that this my picture is in the middle. So what I will do, I will bring it to here and I have the option that like this. You can extend your image up to 4 I want to have. So up to 4 I will take and then up till here. Okay. Now here you can have, suppose for this particular line, because only I'm having this line and I want to range it something. So suppose I'm putting the x-axis range up to 0 to 200 or something, or putting the points like this, or 150 I'm putting the points like this. I'm putting, and this is the linear one, and for y-axis I'm putting some range like the maximum range is 4 only, so I'm putting the 4. Now what I can do, I can press the points here, apply it. So I can press the points using the control option, giving the points at which point I want to have that I can put, and all these sort of values I can get it. These are the point values I have got here. You can also bring it to the line, and these the data it is provided to you for all these things. The data have been plotted for you. Can you see in this lookup table preview, and you can export it to your this CSV format or unified format or something like that. You can have it. Okay. Another option, if I take, suppose another option I'm taking, like here, I'm not changing anything here. I'm making it align. So how many lines we are able to have, like suppose one line, I'm giving value for 1, and values that is dots per line desired is 25. So you can align this, you can select this line and the range it is there, and you can apply it. Now suppose again, if you want to have, like suppose I exceed some values like this. So here you can apply the changes, because this is the simple format. Here we are not able to get. So I'll use the different image for this image. That's why we use that control option, that as per dotted lines, we will be able to get the points. If this is the case, you are not able to get any lookup table preview for that particular page, so you can use it. Now I upload another image, suppose using the output capacitance for this. So fixing up the picture. Image as per the picture. This is the image, another image. Now here, I give it this, like 3 lines. I'm able to see the 1, 2, and 3. I'm giving and submitting. So suppose we have got these dots. So for line 0, you can get the data. For line 1, you can get the data. And suppose if I define the range for like x-axis, I'm defining the range up till 400, and this one range is your 10,000, y-axis range. So you can apply and Here you can get these values. Can you see? For line 1 and line 0. When I applied the range. For linear. You can also switch on to the logarithmic value if you want to have. But here you can see that while using logarithmic scale, minimum and maximum values have to be the positive numbers. So we have to use like that. But still, if I apply, so here you will see no change. So I have shown you two sort of different graphs. Either you can use the auto align chart or something. And if you want to use much more, you can click onto this help icon. There are several shortcuts are given where you can use this tool as per your requirement to getting those tables and other things. So for this purpose, this LUT extraction tool is provided. I hope this part is clear to each and everyone that why do we require this LUT extraction tool. Am I clear?
Yes, ma'am.
Okay, thank you so much. Coming back to the another component which is left, that is the script editor, which we need to see a little bit, and rest we will be performing as we will be moving ahead with our models. Suppose here this is the script editor. So here you can find we are having two window panes. You can see that is here for writing the program, and here you can see that it is embedded with Python 3 or system or custom. You have the option either you can use the Python which you have installed onto your system, or you can customize it. Sometimes when I used to on some programs, so some are the inbuilt programs which we can run only using through embedded Python 3, and for other programs which we can use the Typhoon HIL script editor, but suppose some libraries are missing a part of that, so we can use the system library with the additional library. That part we can do. Now here you can find two window panes. Here when I am writing it, it doesn't mean that you have to learn the Python for operating on this Typhoon Hill, because we have the API wizard. I'll show you. First I'll load one part for you, that to show you the script editor, because writing program again it will take the time. So in a script editor examples, when you will find, suppose for Bode plot I'm taking, so that you can get. Now my file is already saved. Okay. So I will just run this program, and here in the console you can find that script is running and the script has been completed. And here you can find the two figure window pane. It is open, figure 1 and figure 2 as the command which has been given. So this one is the figure 2 one and this one is the figure 1. So here I just drag it for the simplicity. And here you can find that we have the Bode magnitude plot in the figure 1 and Bode phase plot in the figure 2. So this is how you can use it. But in our Typhoon Hill, I just show you the purpose that script editor can also be used for writing the programs. Now my script has already done the result I required. So I will stop it from here and my script is complete. Another window pane you can open. This is the in the view option. When you will go to the view option, check on the API wizard. So this is the third window pane. Here you can directly insert your model. You can directly load your model. Suppose going to the library. Suppose if you want to load any model for RLC circuit or something, you can load it. Okay. If you want to load the settings files, you can directly load it. You don't have to write the program for this. But if you wish to design some sort of, if you're skilled with the programming part, so that also you can do. Suppose I load one file. I load one file for this RLC. And I'm going to save it for you as on some different location on your NIT Delhi part. So suppose here I am writing RLC. So I will save. So actually this program is for the schematic model. I want that my schematic model should be saved. Now I will run this script and see. So model is successfully compiled and it is completed. I will check to my folders. where I saved it. So there you will find one schematic file. So see, this is the file. You can see 27 June 1525 schematic editor. This is saved here. I wrote the program for the RLC example. And if I wish to open it, so I just open it like this. You can see the same file, open model. And the location where I saved it. This is the file. You can note down the date and the time. 1 minute has passed and see. This is the file. It is uploaded. Okay. I just close this one. Means this is the purpose you can else use for the script editor, and this you need not to learn about this. I already told you that already we have built API, that is the auto programming interface. You have to directly insert the command, nothing else. How? I will show you by using a simple model. So this is about the script editor. Now I will stop. Already the script is completed. I'll close this script editor. Coming towards the new schematic. Now how you will come to this new schematic part? Now when you will go to the file and go to the new model, it will ask about the several questions like hardware product 402, yes, configuration ID 1. Now I remember from the configuration ID I need to show you the device table. So this is the 402 device table. You can see you are having the 6 configurations. Now in each configuration, how many number of SPCs, how many number of machine solvers, how many number of signal generators you would like to use, that all the things are given here. Okay, how many like time varying elements and non-ideal switches, I told you that it is absent in configuration 1, configuration 2. These are available in configuration 3 and 4, and in rest of the configuration it is absent. Similarly, if you want to switch any device, suppose HIL 404 suits you, so you can again go through the configuration table. So this is the HIL 404 is having the 5 configurations, and similarly you can find similarly for other series also. But as for the first user, first time, you can go with the exact setting that is by default which is present. That settings you can move ahead without any hesitation. And in simulation method, again, you can have this exact, trapezoidal, Euler, and bilinear. So I'm using exact here. And simulation time step, if you wish, you can change. Otherwise, with auto, I can go ahead. And next, and then finish. So this kind of a window will open. And then you can start with your schematic portion. This is the schematic library. Here in this, you can directly, you have the option for opening the model. Okay, and you can also have the model settings if you would like to change the configuration while working on the model and you felt that no, with the component which you have used or you want to use, that's not present in this particular configuration. By going to the model setting, you can change the configuration. That could also be happen. Here you have two options. From here you can compile model, and from here you can compile and directly load model to your SCADA. And here it is the model initialization when you will going through the hands-on some parts or some values if I would like to give and don't want to insert in the model, just want to have direct change from here. So I can insert some of the like simulation time step. I just give it here, and if my results are not coming or filter values, I can give it here. So I will directly change it from here and again compile if, without going into the component part. I can go through. This will help you to best fit the screen, means your model could be best fitted to the screen. And this is zoom in and zoom out. So these are the options available in Windows, like new schematic window you are already open. In view model, you can have all these options. This is given. Now, if you would like to open any example model, so you can open example model that will directly explore you to the path which is present in examples. You can click any of these, like suppose if I click on any of this, like general power electronics, this part, you can click on this part, you can open the model, and you can compile and load model to the SCADA like this. And from here, when you will compile, it will directly load model to the SCADA. Currently, I am working on virtual mode, but I hope that by tomorrow you will be seeing the real-time mode as well. So this is by the time it is loading model. So here you can find the console messages. You will find here some console messages like here. For device ID 0, actually don't confuse with 0 because in Typhoon Hill our counting starts from 0, 0, 1. Like if I'm connected to one device, I'm using HIL 402, that is in virtual mode, so it is 0. If I will use 2, so it will show 0 for HIL 0. Separate one, HIL 1 means a different one. So HIL 1, that is the 402 other device if I'm using. So here the counting starts from device or core, whatever the things, counting starts from 0. Using 2 devices, then 0, 1. Using 2 cores, 0, 1. If I'm using 3 cores, 0, 1, 2, like this, the counting will start. So here all the compilation part it will show for the standard processing core, SPCs, it is showing how many standard processing core you have used. You can use 3 in this configuration and 1 you have already used. So that is about the machine solver and like this. But it's a request whenever you are compiling these models, do not make any changes in this part. So similarly, it was the inbuilt model. I just selected and I started the simulation. Simulation is running on. So these are the model controls. Here we are seeing the grid mode with the harmonics. When I will switch on to the nominal, it is changed to the nominal. Can you see without stopping the simulation, I can make the changes like that. So this is a kind, and do not make changes in the example models. If you want to work with any of the example model, you can directly copy the complete model into the other schematic, save as at other folder. Otherwise, these models are going to work as a reference for you if you make any changes. So you won't be correct your things like that. So this is the way you can open and explore your example models. In fact, it is on the control center also given on directly on the example models. You can directly explore each of these things like this. Then in the documentation hub, when you will proceed, you can go through all these documentation part for APIs, for DSP interfaces, technical notes regarding thermal modeling of power electronic devices, SCADA, Modbus, communication protocols and all. So you can click and you can explore the document that is present in the documentation hub. Now this is the license. Suppose these are the licenses I am using. So for me, there is a left. So I was asking this sort of a screenshot you can send us and we will get back to this. Now we can have one small hands-on. I hope you understood the console message and this detail of the compilation report present in the console message. You can use it in your research work or the paper work. You can use it like that. Okay. Now for this new schematic, we'll start one hands-on like it. So just to give you a view for that. Meanwhile, I request the co-ops team to post the link for the HIL Academy so that they can register, because at the end, if I am going to get the time, I will explore them through HIL Academy as well. Okay. So for this part, from the converters library, suppose I'm taking any converter. I have took the single phase inverter. I hope it is visible to each and everyone.
Yes, ma'am.
Today I am going through a very simple hands-on just to explore through the libraries, and as we will be exploring the library, you will be definitely known to the components what we are having. Like today I have used the converter library. So there are a number of converters it is given buck boost, buck, and then we are having IGBT legs also, MMC leg, NPC leg. All these legs are available. Then we have 2 diode full wave rectifier thyristor. So all these converters are available. So just then from the sources, if I would like to have right now, currently I would like to have the voltage source. You can use the symbol to rotate it, and you can connect it. You have to only drag and drop and connect. This is the part you can do. Well, there are several other components are also available like battery cell, fuel cell and ground. And you can open this and you can explore as per your requirement. Even PV panel and other things are also happen. Like if I want to reduce some space, so I'll just make it. Now, if I would like to name it like here, I just want to name it as V input. So I'm naming it as V input. I can name it. If you want to give some values like this here, you can change the nature of the source, but I'm not changing here. I'll make a change on the SCADA itself as per my requirement. I want to have a voltage measurement. So here I'm dragging a voltage measurement from the measurement portion, just connecting it. And here, this is the inverter voltage. So INV stands for inverter. I hope all of you got the thing that how to change the name. You have to simply click on the name and this name will be changed. Okay. Suppose if you would like to take the feedback or so you can enable this signal output with the execution rate. So this will be enabled. You can see a different probe means you can take the signal and can give if you want to input it to somewhere, you can input it like this. You can get. But right now I don't want, so I'll just untake it. I hope these points clear.
Yes, ma'am.
Then now if you want to use some filters, so you can have from the passive components like inductor. I'm using one. Now see this variable capacitor, variable inductor and resistor, these are mentioned, but these are in gray color. It means in 402 we can use, but what is required, we have to change the configuration. Right now I'm working in configuration 1, you have to change the configuration 2 if you would like to use that. So for using that, you need to change the configuration. I used one inductor, another one I'm going to use the capacitor. And needs the for current measurement, fetching one current measurement. This bubble should come and plus sign, so you can make a note and that will be easy for you to do it. Then get a register for the load and this and another voltage measurement, fetching. So whatever the black part you are looking right now, I haven't designed any controller parts, which is like plant. So here you can name this V load and this one you can name it as I load. This one you can name it as R load. Now when you will click onto the single phase inverter, so here the options are given that you can have digital input per switch, digital input per leg, internal modulator and model. Suppose I click on the model. So now this pin you got it like this. Now you can design as per your means whatever the control option you want to give, you can design it and you can give it. Suppose right now it's okay for me for digital input per switch. And if you want to know about the single phase inverter, like about the legs and other things, so here you can go through like this. When you will click on the help icon, such sort of a window will get open. Now this is the leg configuration. You can see S1, S2, S3 and S4. how they are arranged. Now, how you can use it as internal modulator, how you can use it as switching enabled or like this, how you can go through the losses calculations. So for that purpose, you can do it like this. Okay. Coming back to our schematic part. So now I'm okay with all these parts.
How did
So
you get
I'll
the
just save this model because before compiling it needs to be saved. So I'm going to save it in your folder, saving it single phase inverter, digital input per leg, digital input per switch. So it is digital input per switch. I'm saving it. So now my model is saved. Suppose I make some changes or even you can see the star mark will always indicate that your model is not saved. Okay. So please, if a star mark is coming and if you want to save your model, you can save it. This is the symbol. Now I will directly compile and load model to the SCADA for this part. And it will load model to the virtual HIL. When I will be connected to the real-time mode, it won't ask that I want to load my model to the virtual mode or not. It will directly load model to my SCADA. Excuse me. Now here, the option you have, create new panel, open panel, because I want to create a panel. I want to design my own panel for this thing. I just open this. Here I'm stretching it. So this is the SCADA library, means the widgets to give you the feel like panel. So you can use this SCADA. These are the model control options. Suppose first and foremost, capture and scope I will take. Bring the capture and scope. It is given in the monitoring section. Double click on it. You can add your signals. Like suppose I want to add my signals. I want to see that is my input. Check on the viewport. If you won't check on the viewport, the viewports won't come to you. Then reload. Then I load. And on other part, we can have C1 and L1 if I want to have. If you would like to see the filter things that you can. I've checked C1 and L1 on the same viewport. If you are having any digital signals, so you can add that, but currently we don't have, so we will not add. Back to the analog portion. So you have both the portion. Now here the grid layout came as like grid, or you can make it as vertical also. Now for this portion, sources I haven't given. So from the here I will give the manual source. Like I'm giving like 30 volt or something. Some value you can put it like that as per your requirement. I'm giving this value.
આપણે ખબર છે વિડિયો ની નીચે કઈ એડિટિંગ કરવું તો કેમ થાય ખબર છે વિડિયો બને છે અને આમાં કઈ એડિટિંગ કરવું કાંઈ ખબર કેમ
Is there any problem? I
ના
think Mayank Belani.
નીચે નામ ને આવી જાય બધું
Mayank Belani. Okay, Chitrashri has raised the hand. Is there any issue? I'll just run the simulation. Now here for the switching blocks, come to the switching blocks and I'll change the configuration. One bottom and one top, keeping it as 1 and rest as 0. So here you can see okay, one more thing, one more signal we need to add, that is V inverter we can add. So instead of this L1 and C1, I'm adding one more signal, that is V inverter. So here in our switching blocks, we can find that just click on this switch control. And my first configuration is this 1001. So you can find the negative half cycle we are getting, negative cycle we are getting here. As I change the configuration back, so this is, we will get the positive cycle. So here you can see that with this, the reverse configuration 0110, we got the positive cycle. So this is the digital input per switch, means we are giving control through the switches. Now for the same thing, like for sources, which I made manually here, I can put a slider also. Like suppose I put a slider and you can double click on this widget. You can edit in code editor. When you will edit in code editor, bring the cursor to the 7th line after these green line. Green lines are the comments with hashtag like this. Go to the source setting. Click and insert the code. Here you don't require to learn the code or anything. You just wrote the code. And 00, what you will do, because you want your value should be changed, so you will definitely use this. As you will write input value, this will come input value, that is value is in capital, V is in capital, rest of the spelling is in, and enter and close it. If you have forget to save, so save your code. No, see your slider is working or not. And as per your slider, you can see the changes. These are the changes going on. Now stop the simulation here. I will make a small controller for you here in the schematic. Come back to the schematic. Make the control option. Give the control option internal modulator. I'm not changing any sort of anything. I'm not changing. I'm just keeping it as default, not using any calculated value or something. But if you want like to use, you can use it. That you can do it. Okay. Internal modulator I have taken. So okay. Now here inside C, here there is some value for L1 and C1. I will change the value. I won't make the, so I will write LF for L1. And for this one, I'm giving the value capital C and small f. Okay. And now for this, inside the model initialization, I'm going to write one value, that is any value I can give. I'm just giving the random value. If I could get the results, it's okay. Otherwise, you can make an improvement over to the filter values or something, because that is only we require to do. There is a 36 of a little bit power minus 6. So taking it. So okay. So see the filter values which I gave here LF and CF, that I have assigned here, and press it OK. Now inside this, for enable, I am going to give the SCADA input. Now whatever the blue portion you will find out, so that is our controller which we are designing. So inside this sources you will find, inside the signal processing library, inside the sources you will find the SCADA input. I'm giving the SCADA input and naming it as enable. Enable. Named it as enable and connect it through. Now here double click on this SCADA input. Here the signal type will be real. Minimum value I'm going to keep it as 0 and maximum as 1. Now here execution rate I'm going to name it as TS. I will be writing the same thing. But in case if I need to change this execution rate, I can directly change it here. No? Otherwise, I have to click on the component and get through all these things. So this is TS 100 e to the power minus 6. So this is I'm taking. So this is. Now for input A and B, I'm directly taking the sinusoidal source. You can also take ABC signal that is also present in our library. Okay, I'm just hiding the name for both. So hide the name so that it should look a little bit nice. I'll just rotate this like this and connecting to the input A. Again rotate it like this and connect it to the input B. Now click on this sinusoidal part. Input A, which we have given. So here I can put, if even if you don't change the execution rate, it's okay because the value is same which we have given in initialization, but it would be better if we can change so that if I'm making change, so it should not show the error. So here the phase is 0, 1, 0 and 50 like that. This DC offset we have taken at 0 like that and it is okay. Inside it, here I'm going to change the phase, that is phase, I'm going to keep it as 180. For the another input, now it is done. Now see the star mark is coming, it means my model is not saved. So I will save this model and again compile and load model. Before compiling and loading the model, we can increase the load also up to 1 ohm or 10 ohm or 100 ohm, whatever you want, you can do it. I'm just compiling the model and let's see. By providing the controller part, what happens? Now here, when it is compiling model and loading back to the SCADA, that means at that time it is interpreting line by line each and everything. It is building our virtual HIL model. Okay, so that is the process going on. Now in this SCADA inputs, enable the SCADA is 1 because we gave the value. To enable it, we need to make the value 1. If the ping surface is coming at the background, that means your value is not validated. So just press enter to make the background white and okay. Now come back to the switching control. I'll make all of these switch controls 0 and untick this switch control option. And now run the simulation. So it is coming like this.